How's it, grade 11s? So today we're going to be starting on calculus, and the first section is going to be this chapter 23, differentiation using first principles. Okay, so this is quite a big one, and you'll even learn about it next year in core maths. So how it works is, if we look at just a normal graph like this, okay, and whatever graph it is, f of x, I choose an x value, and I go up to my graph, and I will get an f of x value. Just remember that that's your y value. So x value, we will get a y value for on our graph there. Now, if I choose some step, whatever it is, and I'm just going to choose a step of h units, okay? So if that's h units, then this x value over here will be x plus h. For example, if that was 2, and I chose my step size to be 3, that would be 2 plus 3, okay? And for this x value, we will also get a y value. Okay, and our y value there will be f of x plus h, for whatever x value that is, okay? And if I make this point A and make this one point B, I can write down the coordinates of A and B. So the coordinates of A would be x and f of x. And the coordinates of B will be x plus h for our x value, and then f of x plus h for the y value. Okay, and now what I'm going to do is I'm going to find the gradient between these 2 points here. Okay, so we know that the gradient would be equal to y2 minus y1 over x2 minus x1. All I'm going to do is just substitute these points in. So my y2 value would be f of x plus h minus y1, which is f of x, all over x plus h minus x. And you can see here that at the top, the numerator, we're just left with f of x plus h minus f of x. And then the denominator, you can see that the x values will cancel, and we're just left with h. So that is the gradient between these 2 points A and B. And what we call this is, we call it the average gradient. So this here would be called the average gradient. So whenever we talk about the average gradient, we're talking about the gradient between 2 points, okay? But now what happens if we want to work out the gradient at a single point? So for example, I want to know what is the gradient at A, okay? So what we need to do is we need to make a tangent at that point A. And the gradient of this tangent at that point will be the gradient at point A. So how do we go about doing that? Well, you can see here, if I make this h value, the step size, 10 to 0, all right? That means that this point here will come closer and closer and closer and closer to this actual x value. So I'm just decreasing the step size, and I'm making it approach 0. That means that this x value, as it tends to 0, x plus 0, would be x. That means that this point here will move along the graph and come closer and closer and closer until it is on A. So what we're going to do is we're going to take our average gradient, and this is how we denote it now. F dashed of x equals the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, I've just taken the average gradient. I've set the limit as h tends to 0 of the average gradient. And the notation for that is f dashed x. And this is the gradient at a point. Okay, And there's many names for it, as you can see here in your book. It says here, first principles, definition, method of limits, or the H method, okay? This formula is given on your formula sheet, so you don't need to know it off by heart. But whenever they say by first principles, you must do with this formula, okay? Another thing, grade 11s, what I want you to highlight in your book here is just this point over here where it says a function is only differentiable if it is continuous. In other words, the derivative does not exist at any point where the function has a removable or jump or essential discontinuity. So in other words, we can't have anything like this or a jump or something like that. It must be continuous throughout its domain, okay, for it to be differentiable. So just highlight that for me. And for today, this is the formula that we are going to be using, okay, for the examples. So if I go to the first example, so EG1A. It's saying determine the following derivatives from first principles. So we've got this function f of x equals x squared minus 2x. Okay. Now, as you saw from that previous formula that we had an f of x plus h. And that's what I'm going to figure out here. So what have I done? I've just changed the x to x plus h. That means I must change all of these x's here to x plus h. So we get x plus h squared minus 2 times x plus h. I'm just going to simplify this. And we get x squared plus 2xh plus h squared minus 2x minus 2h. Okay. Now I have f of x plus h. That one and that one. So I'm just going to write out the formula. F dash x equals the limit as h tends to 0 of f of x plus h minus f of x all over h. I'm just going to substitute these two in. So I'm going to be using this one here, and I'm going to be using this one here in this formula. So we get the limit as h tends to 0 of f of x plus h is now going to be this thing, x squared plus 2xh plus h squared minus 2x minus 2h minus, and our f of x is x squared minus 2x all over h. Right, so as you can see here, this negative here, if we distribute it in, will make this minus x squared plus 2x. So x squared minus x squared will cancel, and then we've got minus 2x plus 2x will cancel. So basically this cancels with this. And we're just left with all of that stuff inside there. So we get the limit as h tends to 0 of 2xh plus h squared minus 2h all over h. Okay, and another thing, grade 11s, what I want you to note here is I keep writing this limit as h tends to 0. And I'm going to carry on doing that until I take the limit. Okay, in the numerator now, I can take out a common factor of h. And we're left with 2x plus h minus 2 all over h. Now this h will cancel with this h, and we are left with the limit as h tends to 0 of 2x plus h minus 2. Now what I can do is I can take the limit. And the reason why I couldn't take the limit initially is because if I made h 0, I would be dividing by 0. And as you know, we can't do that. But we've eliminated that issue now, and now I can take the limit. So wherever I see an h, I'm going to make it a 0. So now I can drop this limit. So we got 2x plus 0 minus 2, and this gives us 2x minus 2, and that is f dashed of x. All right, and that's our final answer. Now you guys are probably thinking, well, what is this? Well, this is the derivative function of this function over here, okay? Because if I had to draw this up, this would look like a parabola, okay? And you can see that the gradient is continuously changing depending on what the x is. And that's what this is going to describe. I can put an x value in here. For example, if I put 2 in there, I get 2 times 2 is 4 minus 2, which is 2. So I know that the gradient at this point is 2. Okay? And that's how powerful this is. We can work out the gradient at any point on a graph. All right. If I go into example B now, here they're asking us to find the derivative of g of x equals x plus 1 in a square root. Okay, now don't get confused now that it's a g of x, it's the same thing, okay, as f of x. I'm going to find now g of x plus h. So I'm going to change every x in here to an x plus h. So we get x plus h plus 1, all in a square root. Okay, so g dashed of x is equal to the limit as h tends to 0 of g of x plus h minus g of x all over h. Okay, so now I'm going to substitute this in, and I'll substitute this in. So we get the limit as h tends to 0 of root x plus h plus 1 minus the root of x plus 1 all over h. Now this one's a little bit different from the first one because you can see that if I distribute this negative in, we're not going to get any cancellation. So what I need to do is I need to multiply by the conjugate, okay? And this is something that you guys learned in grade 10. So the conjugate I'm going to multiply is the conjugate of the top, okay? So I'm just going to rewrite this out, but just push it across here. So we get equals the limit as h tends to 0 of, I'm just going to drop the brackets as well. So we get x plus h plus 1 minus x plus 1 all over h. And here I'm going to multiply by the conjugate. So multiplied by x plus h plus 1 in a square root plus x plus 1 over x plus h plus 1 plus x plus 1. Okay, so in the numerator, we've got a difference of 2 squares basically, so the inner and the outer terms are going to cancel. So I'm just going to multiply the first with the first and the last with the last. And we get the limit as h tends to 0. So that multiplied by that will just be x plus h plus 1 minus that times that, we just left with x plus 1 all over h times this thing at the bottom here, x plus h plus 1 plus the square root of x plus 1. All right, so let's have a look at the numerator and see what we can do there. So we've got x minus x, that'll cancel. We've got 1 minus 1, that'll cancel. And we're just left with h over h, x plus h plus 1 plus x plus 1 in a square root. Now, this h and this h will cancel, and that is good, because you remember we want to try and get rid of it in the denominator because we cannot divide by 0. And what I'm left with is 1 over x plus h plus 1 plus x plus 1. Now I can take the limit. So in other words, wherever I see an h, I'm going to substitute it as 0. And we are left with, so that will be 0, that will fall away, and we're left with x plus 1 in a square root plus x plus 1. So we are left with 1 over 2 x plus 1 in a square root. And this is g dashed of x. All right, grade 11s. I think for now I will leave it there. I just want to get you guys into this slowly. So from the homework, what I want you guys to try now is exercise number 1. A, B, C, and D for me, please. That's all for now. Thanks, grade 11s.